You're welcome back to another session on the probability series. Now we go to multiplication rule. Now the multiplication rule, as you can see, it involves two things. Please, like I said for the addition rule, when you are working on the multiplication rule, it involves two events that are either independent or dependent. Two events that are either independent or dependent. When are two events said to be independent? It's different from the addition when you have mutually exclusive and non-mutually exclusive events. So for the independent event, it means this event, the occurrence of one does not depend on the other one. They can occur differently. They can occur at different times. The occurrence of one will not affect the other one. So that means it's independent. We have a lot of examples of independent events. I mean, events that the occurrence of one does not affect the occurrence of the other one. Then the other ones to dependent events. That actually means we have there are events such that the occurrence of one will affect the occurrence of the other one. Okay, let me just give you an example that you will have come across in probability. When you have certain number of balls and you have to pick what's the probability of picking one of them. You want to see with replacement. With replacement means it is a dependent event. So when it is replaced, it will affect the outcome of the other event. So the with or without replacement, these are cases where you use your multiplication rule and they are the dependent and independent events. Now two events A and B are said to be dependent if the occurrence of the first one affect the occurrence of the other one. Okay, exactly what I said. What of the independent? Let me see if I can have an example on that. Okay, we have, let's work with what we have on this board. But another thing I need to take note, the note we need to take note of is when you are dealing with multiplication rule, endeavor not to jump at the question. Confirm if it's dependent or independent event, then you can go together. And two things are common. Look at these two words or conjunctions also that are written in a different color. You see this, both and. Watch out for them in your questions. So when you are not having, look at this question. I use this same question when I was solving for addition rule, but it was having and or, and you could have either. That is for addition rule. But here multiplication, you are dealing with both, or you have and. These are the two things that you already know that they are. You are using your multiplication rule. So let's get to work. Then the probability, when you're dealing with multiplication rule, this is what it means: probability of A and B. Probability of A and B. That's what this means. So these are written it out in the probability form. That means probability of A times probability of B. So let's go. This is what we use to do your solvings. Question 1. In a basket of fruit, there are 5 grapes, 10 apples, and 8 oranges. What is the probability that the fruits picked are both grape and orange? Now, you know how to calculate your probability. Probability for grape, of course. Grape 5. Upon, what do you calculate? The summation of F? 1523. Good. Then the probability of oranges, that will be 8 upon 23. Then the probability that they are both grape and orange. First, this is an independent event. the occurrence, the probability of picking or the event of picking a grape does not in any way affect the event of picking an orange. So which means the probability of G and orange will be the probability of the grape times the probability of picking an orange, and that will be 5 over 23 times 8 upon 23. And what will that give us? That should give us 40 upon 23 times 23, 529. You get that? As simple as that. Question 2. Next question says, a packet contains 6 red, 5 blue, and 4 black identical balls. 2 balls are picked at random without replacement. Something will happen. Find the probability of picking a red and a black ball. So they said 2 balls were picked, but when the first one was picked, it wasn't replaced. Then the second was picked. So of picking a red, probability of picking a red, first, probability of R, a red will be 6. How many balls do we have altogether? 11 plus 4, that is 15. The probability of picking a black ball. Don't forget, there was no replacement. So what do we have? It actually means the number of balls we have has reduced from 15 to 14. Though the number of balls for blue should not reduce, because blue wasn't picked. The probability of picking red, we have number of red is 6 upon the total number of balls. Then probability of picking blue rather, we have how many blue balls? We have 5. Then the number of balls we have now will be 14. It is without replacement. So this is where you have a dependent event. Yes, a dependent event. So take note of this. It is, of course, you are using the multiplication rule, but it is not just a independent event. It's a dependent event. So we have this that's affected the probability of picking, or the event A has affected the occurrence of event B. So that's now probability of R and B can be equal to 6. Okay, let me write that out. Okay, yes, it's still what you know. Probability of A times probability of B, 6 over 15 times 4 upon 14, and that becomes 24 upon 15 times 14 is 210. Think 2 can still break that down. 2 here we have 12. 2 here we have 2 in 21 is 10 million. 1, that's 105. 3 here we have 4 upon 3 is here. 3 in 10 is 3. Then in 15 you have 5. The answer is 4 upon 35. So that's the probability of picking a red and a blue ball from the information that we have. Get to solve more questions regarding multiplication rule, use of to differentiate easily your dependent and independent events. Then if you have any question, any suggestion, anything that is not clear, use the comment box, or you reach me on my contact. You have plus or minus, you have plus 2 3 2 3. Okay, since it's taking out time, just write it. 2 3 4 8 1 6 4 8 6 9 4 7 0. Thank you.